Welcome to the Purdue Global Academic Success Center's presentation on classification of matter. In this seminar, we'll cover the following learning outcomes: introduction, pure substance, atoms, molecules, mixture, states of matter, and the conclusion. Introduction. Matter is a term used to describe anything that has mass and takes up space. According to the principles of modern physics, the various types of particles each have a specific mass and size. Fundamentally, matter is composed of elementary particles called quarks and leptons, both of which are considered elementary particles in that they aren't made up of smaller units of matter. Quarks is a group of subatomic particles that interact by means of a strong force and combine into protons and neutrons. Leptons is a group of subatomic particles that respond to weaker forces and belong to a class of elementary particles that includes electrons. Matter can be classified into a pure substance or a mixture. Pure substances can be divided into element and compounds, and a mixture is divided into a homogeneous mixture or a heterogeneous mixture. Classifying of matter. Matter is divided into two categories: mixtures and substances. Mixtures contain more than one kind of matter. For example, cola is a mixture of carbonated water, corn syrup, caramel color, phosphoric acid, natural colors, and caffeine. A pure substance is a substance that has a constant composition and properties and contains only one kind of particle. A pure substance is composed of an element or a compound. All elements are mostly pure substances. A few of them are gold, copper, oxygen, chlorine, diamond, etc. Compounds such as water, salt or crystals, and baking soda, amongst others, are also grouped as pure substances. An element is a substance that cannot be broken down into a simpler format. They are distinguished by a unique atomic number. The elements are organized by their atomic number in the periodic table, which highlights elements with similar properties. Example of the periodic table. The periodic table is a tabular array of chemical elements organized by atomic number, from the element with the lowest atomic number, hydrogen, to the element with the highest atomic number, oganesson. The atomic number of an element is the number of protons in the nucleus of an atom of that element. A compound is a pure substance that contains two or more different elements in fixed proportion. The elements are chemically bonded. When the elements come together, they react with each other and form chemical bonds that are difficult to break. These bonds form as a result of sharing or exchanging electrons between atoms. Examples of a compound include hydrogen peroxide, water, and common table salt. An atom is the basic building block of chemistry. It is the smallest unit into which matter can be divided without the release of electrically charged particles. It's also the smallest unit of matter that has the characteristic properties of a chemical element. The atom is the basic building block of chemistry. Molecules are made up of one or more atoms. If they contain more than one atom, the atoms can be the same. An oxygen molecule has two oxygen atoms, or different. A water molecule has two hydrogen atoms and one oxygen atom. Biological molecules, such as proteins and DNA, can be made up of many thousands of atoms. In chemistry, a mixture is a compound made up of two or more chemical components that are not chemically linked. A mixture is a physical blend of two or more substances that preserve their identities and are blended in the form of solutions, suspensions, or colloids. Types of mixtures. There are two main categories of mixtures: homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures can be defined as mixtures that possess the same properties and combination throughout their mass. Sugar mixed with water is the most common example of a homogeneous mixture. Heterogeneous mixtures possess different properties and compositions in various parts, i.e., the properties are not uniform throughout the mixture. A mixture of sand mixed with salt is an example of a heterogeneous mixture. Characteristics of mixtures. The constituents of a mixture are not present in a fixed ratio. The various characteristics of mixtures are discussed below. There is no chemical force acting between the two or more substances that are mixed, but they still exist together. They can either be heterogeneous or homogeneous in nature. The proportions of the substances vary in an indefinite manner. The properties of the mixture depend upon the individual components. The constituents of the mixture can be separated by physical methods. The boiling point and the melting point of the mixture depend upon the characteristic of the constituents. During the formation of a mixture, there is no change in energy. There are 3 states of matter: 1. Gas, 2. Liquid, and 3. Solid. Gases, liquids, and solids are all made up of microscopic particles, but the behaviors of these particles differ in the 3 phases. The following figure illustrates the microscopic differences. Explanation. Solid. In a solid, particles are packed tightly together so they don't move much. The electrons of each atom are constantly in motion, so the atoms have a small vibration, but they are fixed in their position. Because of this, particles in a solid have very low kinetic energy. Solids have a definite shape as well as mass and volume, and do not conform to the shape of the container in which they are placed. Solids also have a high density, meaning that the particles are tightly packed together. Liquid. In a liquid, the particles are more loosely packed than in a solid and can flow around each other, giving the liquid an indefinite shape. Therefore, the liquid will conform to the shape of its container. Much like solids, liquids, most of which have a lower density than solids, are incredibly difficult to compress. Gas. In a gas, the particles have a great deal of space between them and have high kinetic energy. A gas has no definite shape or volume. If unconfined, the particles of a gas will spread out indefinitely. If confined, the gas will expand to fill its container. When a gas is put under pressure by reducing the volume of the container, the space between the particles is reduced and the gas is compressed, according to NASA's Glenn Research Center. Conclusion. Matter can be classified according to physical and chemical properties. Matter is anything that occupies space and has mass. The 3 states of matter are solid, liquid, and gas. A physical change involves the conversion of a substance from one state of matter to another without changing its chemical composition. Thanks for watching.